In the last two videos, we talked about this idea of having an interface called iShape that three subtypes implement, and the idea was that the iShape interface defines these two methods called area and perimeter, and the three classes, circle, triangle, and rectangle, all implement the interface. They all override these two methods, but they all do it differently. Okay? And as I said in the last video, and I scribbled it very crazy-like, that is an idea that's known as polymorphism. Okay? So the idea here is that, if you look at the roots of this word, poly means many, and morph or morphism is dealing with behavior. Okay? So don't confuse this with the other idea called parametric polymorphism. So that's a different idea altogether. That's an idea relating to generics, okay? So that's not what we're talking about, just for the sake of integrated context. So the idea is that we have these three classes, like I said, that all do some behavior, so computing the area or computing the perimeter, but they all do it differently, okay? So that's the mini, or the poly, is the different classes. Morph is the implementations of these methods. They all do the same thing in theory, but they all do it differently in the sense that they all implement these methods differently. Okay? But there's sort of a question here. How does Java know when we say, like, iShape s1 equals new, then some subtype, how does it know to call the correct area method? So if we instantiate this as a circle with some radii, or with some radius, not radii, how does it know to call the area method of the circle class and not one of the others? And that, the reason why it knows how to do that, is via something called dynamic dispatch. So, at runtime, hence the word dynamic, Java will look at the type that S1 is instantiated as. And if it's it'll examine what it is, and since it's a circle, it will know to call that version of the area method. Okay? If you instantiate it instead as a rectangle, then it will call the rectangle version. If you instantiate it as a triangle, it will call the triangle version of area. Okay? So it's only at runtime that Java will know what type this is instantiated as. Well, it'll kind of know it at compile time, but I mean, the main thing here is that at runtime it will determine which area method or which perimeter method to call, and that's the dispatch that's where the dispatch word comes in. So it dispatches based on what type of subtype the class is instantiated as. Okay? So one more thing I want to talk about is the difference between something like, and I alluded to this in the first video, the first of the iShape interfaces videos. If we do something like this versus this. And to be fair, you've probably done this before. So, for example, we would see, I told people to do this when they were creating an array list. I'm not writing it all out, but you get the idea. But a lot of tutorials and books and people teaching array lists will just teach it like this. So the difference here is that you instantiate the class as the subtype and not the interface type. Now, in this case, it's not that bad. There's not really any issues that you run into. The difference here, however, is that C1 will allow us to, if we use this variable, it will allow us to use the set radius and get radius methods. whereas doing that with S1 will not, because these methods are not present in the iShape interface. You can only use methods, you can only call methods on S1 that are in the type that it is declared as. So you may be wondering, why would we ever do this version or this version compared to this version? Then the reason is because we can store S1 in a collection of iShapes. So for example, if you have a collection of iShapes, and this was very poorly written, let's try that again. If we have a list of iShape objects, like this, we can add we can add S1 to LOIS because it is a kind of shape. We cannot add C1 into this list because it's not declared as an iShape. Now, you could cast it and then add it, but that's not really what we want to do. And in fact, there is a way through wildcards to be able to add C1 instances or instances of any of the subtypes into these types of generic classes, but that's beyond the scope of this video. There is a reading about it in the book, but we're not going to talk about it because I don't really see the point. So you almost always want to instantiate a type as the overarching type. So like iShape or something else rather than the subtype like circle or rectangle or anything like that. Because you're using the class as if it were an iShape. If you weren't using it as an iShape, there really wouldn't be any point of implementing the interface. Because the whole point is that we want this to be a polymorphic interface. We want to have this polymorphic behavior. And if you just instantiate it as if you initialize it as a circle, and then instantiate it as a circle, instead of declaring it / initializing it as an iShape, then you lose that polymorphic behavior. Okay? Or at least you lose it in the context of being able to store it in some collection of iShapes, or any method that would receive an iShape instance.